Section 1.6 covers two main topics. One is rounding and estimating, and also about order. We round numbers in various situations when we do not need an exact answer. For example, we might round to see if we are being charged the correct amount in the store, or we might round to check if an answer to a problem is reasonable, or to check a calculation by hand or on a calculator. So to understand how this rounding works, let's look at an example. Round 47 to the nearest 10. Well, 47 is between 40 and 50, but it is closer to 50 than to 40. Therefore, we round up to 50. So here's a number line, here's 40, here's 50, 47 is right here. It's certainly closer to 50 than to 40, so we round up. Similarly, example number 2, round 42 to the nearest 10. Again, 42 is between 40 and 50, but since 42 is closer to 40, we round down to 40. So for the future examples, we don't necessarily look at a number line, but it's always a good idea to keep that in mind, what it looks like. So it's a good idea, if you're in doubt, draw a number line, put the numbers in between where you're supposed to round, and then see to which number it is closer. Now, here's a tricky question. Example number 3, round 45 to the nearest 10. Well, here's 40, excuse me, here's 50, here's 45, so we are right in the middle. So 45 is halfway between 40 and 50. We could round 45 down to 40 or up to 50. We agree to round up to 50, and that is where most of the rounding goes. If it's halfway, we round up. That's a general agreement. Once in a while, you have a difference of opinion about that, but here in this book, and probably most math you'll ever see where it talks about rounding, if it's halfway, we round up. So next we'll be doing some rounding exercises, and it's round to the nearest 10. So here's the number line, here's 30, here's 40, here's 37. So since we are closer to 40, we round to 40. Similarly, we round to the nearest 10. 52 is between 50 and 60, but 52 is closer to 50 than to 60, so the rounded value is equal to 50. 35, for number 3, 35 is halfway between 30 and 40, and as we just talked about, if it's halfway, we round up, so the nearest 10 would be 40. 73 is between 70 and 80, but it's closer to 70 than it is to 80, therefore we round it to 70. 75 is similar to the previous example, number 3. So 75 is halfway between 70 and 80, and again we round up in a case like that, so that the rounded value would be 80, the nearest 10. 88 is between 80 and 90, but it's closer to 90, so the rounded value is 90. 64 is between 60 and 70, but it's closer to 60, so we round it to 60. So here are the steps for rounding of whole numbers. To round to a certain place, locate the digit in that place. Consider the next digit to the right. If the digit to the right is 5 or higher, round up. If the digit to the right is 4 or lower, round down. Then change all digits to the right of the rounding location to zeros. So let's do a couple of examples here. So here it's supposed to round to the nearest 10. So 3 is a 10th place. There are 137, so there are 3 tens. And so since the digit following the 3 is a 7, we round up. And so that's closer to 140 than to 130, so the rounded value is 140. 473, we need to round it to the nearest 10, so we're looking at 73, and so that's between 70 and 80, and since it's closer to 70 than to 80, the rounded value would be 470. $235, so here we're looking at the 3, because we round to nearest 10. So 35 is between 30 and 40, and it's halfway, we round up, so there would be 240. $285, we round that, since it's 8 and followed by 5, we round it up. The nearest 10 would be 9, so it would be 290. So number 12, round to the nearest 100. So here 6 designates a hundredths, and so this followed by 4, so we round down, and so it becomes a 6 followed by zeros, or 600. Here we have 759, 7 designates a 100, and since the 7 is followed by 5, we round up, so this becomes an 8 followed by 2 zeros. $1,871, so we look at the 8 followed by 7, so we round that up to a 9, so 1 and then 9 followed by 2 zeros, 1,900. Here the 100th place is 3, and since 3 is followed by 2, we round down, so it says 3 followed by a 3 and a 0, 0. The next exercise asks us to round to the nearest 1,000. So here the 7 designates 1,000, followed by an 8, so that's greater than 5, so we round up. So we round the 7 to an 8, followed by 3 zeros, 8,000. Here 8 designates the thousands, followed by 4, so we round down. So we have 8 followed by 3 zeros, because we're rounding down. The nearest 1,000. Similarly here, we have 19,343. The 9 designates 1,000, so followed by 3, so we round that down to 19,000. Here we have 68,500. The thousands are here, 8,000, followed by 5. So it means we round up, and that then becomes a 9, so 69,000. For number 20, we are supposed to round 48,968 in 3 different ways: nearest 10, nearest hundreds, and nearest thousand. So nearest 10, so we have 48,968. So the 10 would be the 6 tenths, followed by an 8. So we round that up to 48,970. So that's for the nearest 10. The hundreds would be 900. So followed by 6, we round it up to 10. So in other words, this now becomes a 49,000 followed by 3 zeros. And then for the thousand, 8 indicates the thousands, followed by 9, so we round it up to 9. So that is also 49,000. So nearest 10, nearest 100, and nearest 1,000. Similarly, in number 21, 269,582 to nearest 10, to nearest 100, the nearest 1,000. So we look at the 10, there would be an 8 followed by 2, so we round that down to 269,580, because the 8 is followed by 2. For nearest 100, since this 5 is followed by an 8, we round the 5 to 6, so this becomes then 269,600. 582 is close to 600. And then for nearest 1,000, here we have the 9 followed, here the thousands is indicated by the 9, the 9,000, followed by 5, so that means we round up, and so that becomes 270,000 then. So the next exercises have to do with estimating sums of some numbers, some addends. And so here we round to the nearest 10, which would be 70. And the nearest 10 here would be 20. The nearest 10 would be 40. Remember, we round up to 40. And here the nearest 10 would be 70. So now we just add these numbers. And that's equal to 200. For number 23, we round 650 up to 700. Remember, we are halfway between 600 and 700, so we round it up to 700. And here 685 is closer to 700. We round that to 700. 238, we round that to 200, since we're supposed to round it to the nearest 100. So it's 200. And 168, well, we round that, the 1 is followed by a 6, so we round that to 2, so it becomes a 200. And we add these numbers together, and that's equal to 1,800. The next exercises have to do with differences, and so here we are supposed to round to the nearest 100 first. So here we have 200 followed by an 8, so we round it up to a 300, 9,300. And here we have 6,739, so 700, and 739 is closer to 700 than to 800, so this becomes minus 6,700. And so that difference is equal to 2,600. And here we are supposed to find the difference by first rounding to the nearest thousand. So we have 3,000 followed by 2, so we round that down to 23,000. Here we have 11,698, so we have a 1 followed by 6, so we round it up to 12. So to 2, so it becomes a 12,000. We subtract that, and the difference is, of course, 11,000. So that's how we can estimate the sum of numbers and the difference of numbers. Now, there's a little detail when we talk about rounding. In the sentence 7 minus 5 equals 2, we use the equal sign to indicate that 7 minus 2 is the same as 2. When we are rounding, the answer is usually not equal to the exact answer. So we use the symbol, the two wavy signs, and that means approximately equal to. So you'll see that quite often. The symbol here, approximately equal to. So in the next exercise, we're supposed to estimate the product by rounding first to the nearest 10, and then estimate the product by rounding first to the nearest 100. So at nearest 10, that means 837 gets rounded to 840 because the 3 is followed by a 7, so it becomes a 4. It's 840. Now we round 245. The 4 is followed by a 5, so it becomes a 250. So 50 times 840 is 42,000. Then 200 times 840 is 0, 0, 0. And then 2 times 4 is 8. And 2 times 8 is 16. So when we add this, then that is 0, 1, and 2. So 210,000 would be the estimate when we round to the nearest 10. Rounding to the nearest 100, 837, we look at the 8 followed by 3, so we rounded to 800. And 245, the 2 is followed by a 4, so we round that down to 200. And so 200 times 800 is equal to 160,000. So obviously the estimate we round to the nearest 10 is better than rounding to the nearest 100. And just as you can estimate a product, we can estimate a quotient also. So the next exercise asks us to estimate the quotient by rounding first to the nearest 100. Show your work. So we have 64,534 divided by 349. So to the nearest 100, so we have the 500 and followed by a 3. So it means we round down to 64,500. And we divide that by 349. We round that, since the 3 is followed by 4, we round that down to 300. And that's equal to 215. By the way, a more accurate answer for the actual division problem here is using a calculator, 184.911175. Here's an estimate for tuition. If Alan takes courses online, the cost per credit hours is $198. Estimate by rounding to the nearest 10 the total cost of 12 credit hours of classes. So when we round $198 to the nearest 10, it becomes $200 times credit hours, so 12, you round to the nearest 10, it becomes a 10, would be equal to $2,000. The last learning objective in this section is order. So when we look at a sentence like 8 plus 5 equals 13, it's called an equation. It is a true equation because, for example, 8 plus 4 plus 8 equals 11 is a false equation. Then we have sentences like 7 less than 11 is called an inequality. The sentence 7 is less than 11 is a true inequality because obviously 7 is less than 11. The sentence 23 greater than 69 is a false inequality because 23 is not greater than 69. So here's the inequality symbols. When the point goes to the left, it means less than. When the point goes to the right, it means greater than. And when we have an equals with a bar through or with a slash through, it means not equal to. So it's really important to keep these symbols correctly oriented. And so we'll be doing some examples in a moment here. So in general, for any whole numbers a and b, we read this a is less than b. And that's true when a is to the left of b on the number line. So we visualize the number line. If a is to the left of b, then a is less than b. On the other hand, a is greater than b. That is a true statement when a is to the right of b on the number line. So it's important to keep these definitions in mind. Okay, so left of b on the number line, and here a is to the right of b on the number line. So with that, let's look at some exercises. So the first one is a guided example. Here we have the question a compared to 12. So when we look at the number line, 8 is certainly to the left of 12 on the number line. So it's to the left of 12 on the number line. So 8 is less than 12. Similarly, number 32. Since 12 is to the right of 8, 12 is greater than 8. So notice that 8 is less than 12 is the same as saying 12 is greater than 8. In number 33, when you look at the number line, 76 is to the right of 64, therefore we say 76 is greater than 64. And comparing 64 to 76 this way, since 64 is to the left of 76 on the number line, we say that 64 is less than 76. Similarly, 217 is to the left of 345 on the number line, so 217 is less than 345. On the other hand, 345 is greater than 217. And therefore, and it's to the right of 217, so therefore 345 is greater than 217. I think these are some very simple exercises, but for all of the exercises and all the sections we have done so far, if there's anything that is not very clear to you, I would really recommend to look at the book and do additional drill exercises. Every section has extra drill exercises and also in between sections, so review sections. So make sure you clear up any kind of questions or doubts that you have about any of the exercises. And it's usually in the book, but we can also discuss any lingering questions, anything that's left over during office hours. So this is the conclusion of section 1.6.